Lesson number 3, looking for cations. By the end of this lesson, you should be able to describe and explain the tests for aluminium, calcium, copper, iron 2, iron 3, and ammonium ions using sodium hydroxide solution, and explain how precipitation reactions can form the basis of some tests for ions. Water from rivers and lakes can contain a number of ions. In hard water areas, there are chalk or limestone rocks. The water contains calcium ions. In some areas, copper ions can be present due to industrial pollution. Flame tests are a good starting point for any analysis, but other tests are needed. In fact, a series of tests is often required to find a unique set of results for each ion. The next test usually involves adding a few drops of sodium hydroxide to a solution of the unknown sample. Many metal hydroxides are insoluble, so a precipitation reaction can occur, and the precipitate formed can identify the ion present. The photograph shows the results of adding sodium hydroxide to a number of different ion solutions. Aluminium produces a white precipitate, calcium a white precipitate, copper a blue precipitate, iron 2 a green precipitate, and iron 3 a rusty brown precipitate. Ammonium does not produce a precipitate. The precipitate will be a solid hydroxide of the cation. For example, if the compound was copper sulfate, the precipitate would be copper hydroxide. If the unknown sample was iron 2 nitrate, then the precipitate would be iron 2 hydroxide. The balanced equations for these reactions are as follows: copper sulfate plus 2 molecules of sodium hydroxide will form 1 molecule of copper hydroxide and 1 molecule of sodium sulfate. 1 molecule of iron nitrate plus 2 molecules of sodium hydroxide will produce 1 molecule of iron hydroxide and 2 molecules of sodium nitrate. The table shows that further tests are needed for ammonium, aluminium, and calcium ions. This is because ammonium ions do not form a precipitate, and both aluminium and calcium ions form a white precipitate. However, aluminium and calcium can be distinguished by adding excess sodium hydroxide. In excess sodium hydroxide, the calcium precipitate is not changed, but the aluminium precipitate starts to dissolve. Like the alkali metal ions, ammonium ions form no precipitate with sodium hydroxide solution. To test for the ammonium ion, heat the unknown sample with concentrated sodium hydroxide. If the ions are present, the smelly alkali gas called ammonia will be given off. This can be detected as it turns universal indicator paper blue.